Hello, everybody. All right, so we're going to continue with lesson 10.2, and we'll discuss the independent practice problems on pages 275 and 276 of the 6th grade Go Math textbook. So let's look at number 10. All right, so evaluating expressions. The table shows ticket prices at the movie 16 theater. We're going to let A represent the number of adult tickets, C the number of children's tickets, and S the number of senior citizen tickets. And we have two different prices actually. The children and seniors have the same price. And wants us to write an expression for the total cost of the three types of tickets. Well, if you're an adult, you're going to pay $8.75. So every adult will pay $8.75. So $8.75 times the number of adults plus the number of children. So that would be $6.50 times C being the number of children, plus $6.50 times S, or the number of seniors. Okay. So that's our expression. So 10b, the Andrews family bought 2 adult tickets, 3 children's tickets, and 1 senior ticket. Evaluate your expression in A to find the total cost of the tickets. All right, so we have $8.75 A plus $6.50 C plus $6.50 S. Okay, so there's 2 adults. So substitute 2 for A. There are 3 children. So $6.50, substitute 3 for C. And there's 1 senior. So substitute 1 for S. Okay, and then we just have to follow the order of operations to evaluate the expression. So we have 2 times $8.75 plus $6.50 times 3 plus $6.50 times 1. So we have multiplication and addition. So we're going to do all the multiplications first. So 2 eighths is 16. 75 plus 75 is $1.50. So $17.50. 6.50 3 times. Well, 3 times 6 is 18. And 3 50s is $1.50. So $19.50. And there's only 1 senior ticket. So 1 times $6.50. All right, now we have to add those together. So 19 and 17 plus $6.50. So if we do these two together, we get 19 and 6 is 25, 50 and 50 is 1, so $26 plus $17.50. 50 cents plus nothing is 50 cents, and 17 plus 26 is 43. So $43.50. Okay, C. The Spencer family bought 4 adult tickets and 2 children tickets. Did the Spencer family spend the same amount as the Andrews family? Okay, so let's put back into our expression. $8.75 A plus $6.50 C plus, okay, they didn't buy any senior tickets, so I don't need that. All right, so we bought 4 adults and 2 children's. 4 adults, 2 children. So substitute 4 for A and substitute 2 for C. All right, well, $6.50 plus $6.50 is $13. $8.75 times 4. Well, 2 $8.75s would be $17.50. So $17.50 twice is $35. 35 plus 13 is $48. So did they spend the same amount? No. Okay, no, the Andrews family spent $48, not $43.50. And number 11. The area of a square is given by x squared, where x is the length of one side. Mary's original garden was in the shape of a square. She has decided to double the area of her garden. Write an expression that represents the area of Mary's new garden. And then evaluate the expression if the side length of Mary's original garden was 8 feet. So we know that the area of her original garden was x squared. She's going to double that. So all we have to do is put a 2 in front of the x squared. All right, now we're going to substitute 8 for the x. So 2 times 8 squared. Okay, well, 8 squared is 64. So her original garden was 64 square feet. She decided to double it, and she wound up with 128 square feet. Okay, number 12. Ramon has $2,340 in his savings account. Write an expression for the amount in his account after he deposits D dollars and withdraws W dollars. If he deposits $100 and then withdraws half as much as he deposited, how much is in his account? So he has $2,340 plus whatever he deposits minus any withdrawals. Okay, withdrawals mean you're taking it out, so you don't have it in your account anymore. Deposits, you're putting it in. All right, so that's our general expression. So now let's substitute based on the criteria of the problem. D is 100. W, he withdrew half as much as he deposited. Well, half as much is 50. All right, so we have addition and subtraction. So we're going to add and then subtract. We're just going to go left to right. So we have 2440 minus 50. So we're going to get 2390, which makes sense. We're basically, if he's withdrawing half of that, he's really only putting in $50. So 2340 plus 50, 2390. All right, 13. Evaluate the expression for 6x minus x squared for x equals 0, x equals 1, 2, 3, 4, 5, and 6. Use your results to fill in the table. So we have 6 times x minus x squared. All right, well, if we substitute 0 for x, we have 0 squared. Well, we know that's 0. And 6 times 0 is 0. So 6 minus 0 is 0. Okay, substitute 1 for x. Well, 1 squared is 1. 6 times 1 is 6. 6 minus 1 is 5. Okay. Now, if it was 2, 6 times 2 minus 2 squared. 2 squared is 4. So now we can multiply. 6 times 2 is 12. Minus 4 is 8. When x is 3, 3 squared is 9. 6 times 3 is 18. 18 minus 9 is 9. Okay. 4. So 6 times 4 minus 4 squared. 4 squared is 16. And now we have 6 times 4 left. 6 times 4 is 24. Minus 16 gives us 8. 5. 6 times 5 minus 5 squared. Do the exponent first. So we're left with 6 times 5 minus 25. 6 times 5 is 30. 30 minus 25 is 5. And 6. 6 times 6 minus 6 squared. 36 minus 36 is 0. All right, describe any pattern that you see. Well, it looks like it's increasing 0, 5, 8, 9, and then decreases 8, 5, 0. So it looks like it's just kind of opposite. Okay, so it looks like it increased from 0 to 9, and then decreases back to 0. Let's see, the values are the same. For x equals 0 and x equals 6. X equals 1 and x equals 5. X equals 2 and x equals 4. Okay. So that's the only real patterns I see, is that it's increasing from 0 to 9 and then decreasing in the same order back to 0. When the exponent is 0 and when the exponent is 6, they are both 0. When the exponent is 1 and when the exponent is 5, they both have a value of 5. When the exponent is 2 or the exponent is 4, they both have a value of 8. All right, 14. Kinetic energy in joules of a moving object can be calculated from the expression a half mv squared, where m is the mass of the object in kilograms. So 1/2 the mass and v is its speed in meters per second. 1/2 its mass times the speed squared. Find the kinetic energy of a 145,000th kilogram baseball that is thrown at a speed of 40 meters per second. All right, so start with the equation. So we have 1/2 mass times velocity squared. Okay, they gave us a mass of 0.145, and they gave us a speed of 40 meters per second. So we have multiplication and exponents. So let's do the exponents first. So 40 times 40 is 1600 times 1/2, 0.145. Okay, well, we can take half of 145 thousandths. So okay, so we're going to get 0.0725 times 1600. Okay, so multiply that out. We know, since we're multiplying by powers of 10, that our answer is going to end in 2 zeros. 6 times 5 is 30. 6 times 2 is 12, plus 3 more is 15. 6 times 7 is 42, plus 1 more is 43. Six times 0 is 0, so the 4 there. Okay. And one, two, three, 4 decimal places. 1, 2, 3, 4. So 116 joules is the kinetic energy. All right, number 15. The area of a triangular cell is given by the expression a half of the base times the height, where b is the length of the base and h is the height. what is the area of a triangular cell in a model cell when B equals 12 and H equals 7? So start with the equation. Substitute. So for B, we're going to substitute 12. And for H, we're going to substitute 7. So we just basically have multiplication, right? So I can group things the way I think would be make it easiest. So half of 12, that's easy. That's 6. So now I'm left with 6 times 7. So 42 inches squared. Number 16. The volume of a pyramid with a square base is given by the expression a third s squared h, where s is the length of a side of the base and h is the height. The length of a side of a square base of a particular pyramid is 24 feet. The height is 30 feet. Find the volume of the pyramid. So volume equals 1/3 s squared h. And they told us the side is 24. So 24 squared times a height of 30. Okay, so we have 1/3 of 24 squared. So s squared times 30 times 1/3. So 24 times 24. Is 576. Okay, so we have 1/3, 576 times 30. I'm actually going to regroup these, okay, using the associative property. And I'm going to take 1/3 of 30, then multiply by 576. 1/3 of 30 is 10 times 576. Okay, we know this is just going to end in 10, so 5,760 cubic feet. Okay, 17. Evaluate the expression. Consider the expressions 3 times x times the difference of x and 2 plus 2, and then 2x squared plus 3x minus 12. And now evaluate each expression for x equals 2 and x equals 7. Based on your results, do you know whether the two expressions are equivalent? And we need to explain. All right, so 3 times x, x minus 2 plus 2. And we have to solve both for x equals 2 and x equals 7. So let's start with 3 times 2. Okay, so when x equals 2, our first expression, do parentheses first. So 2 minus 2 is 0. So we have multiplication, multiplication, and addition. Well, let's do the multiplication left to right. 3 times 2 is 6. So 6 times 0 plus 2 is 0 plus 2. So when this first expression is 2, when it's 7, okay, so step 1, substitute 7 for x. 7 minus 2 is 5. So now we have 3 times 7 times 5 plus 2. So 3 times 7 is 21 times 5 plus 2. So 5 times 21 is 105 plus 2 gives us 107. All right. So when x equals 2, the answer is 2. When x equals 7, the answer is 107. And now we need to do the same thing for the second expression. So 2x cubed plus 3x minus 12. Substitute 2 for the x. So we have 2 times 2 to the third plus 3 times 2 minus 12. Do the exponents first. 2 to the third is 8. Okay, now we have multiplication, addition, multiplication, subtraction. Do the 2 multiplications. Okay, we have addition and subtraction, so we're just going to go left to right. 22 minus 12 is 10. Oh, I just noticed I wrote the problem wrong. It's not 2x cubed, it's 2x squared. That's going to change my answer, isn't it? All right, so 2 squared is 4. That gives me 8 plus 6. Well, yeah, that's significantly different. 8 plus 6 minus 2. 14 minus 12 is not 10. 14 minus 12 is 2. So when x equals 2 in this problem, the answer is 2. Okay, so they're the same right now. Now let's substitute for 7. 2 times 7 squared plus 3 times 7 minus 12. All right, do the exponent first. So 2 times 49 plus 3 times 7 minus 12. 2 times 49, that's 98. 3 times 7 is 21 minus 12. Do the addition first. So we have 9. So 119 minus 12 gives us 107. So when x equals 7, the answer is 107. All right. Based on our results, do you know whether the two expressions are equivalent? Well, they don't seem to be. Oh, let's wait. Okay, so let's see. When x equals 2, we got 2 in both of them. When x equals 7, we got the same answer. All right, B, evaluate each expression for x equals 5. Okay, so 3 times 5 times 5 minus 2 plus 2. So we have multiplication, so 3 times 5 is 15, times 5 minus 2, so we have to do we should have done the parentheses first, but in this case it's not going to change my answer. So now I'm left with multiplication and addition. 3 times 5 is 45, plus 2 gives me 47. All right, now let's put 5 in the other expression. 2 times 5 squared plus 3 times 5 minus 12. do the exponents first. 5 times 5 is 25 times 2. 3 times 5 is 15 minus 2. So we're with multiplication, addition, subtraction. So 2 times 25 is 50 plus 15 minus 12. 50 plus 15 is 65 minus 12. So we'd get an answer of 53. Well, when x equals 5, the expressions are not equivalent. Because one answer is 47. And the other answer was 53. All right, 18. Marjorie evaluated the expression 3x plus 2 for x equals 5 as shown. 3 times x plus 2 equals 35 plus 2 equals 37. What was Marjorie's mistake? Okay, she did substitute 5 for x. But didn't multiply. Three x means 3 times the value of x. So 3 times 5 plus 2, the answer should be 17. Okay, so all she did was put the 5 next to the 3, and now she's got 35 plus 2. So that's not right. This number missing is not a 1 digit. It means 3 times that number. So 3 times 5 is 15. 15 plus 2, 17. All right. So that ends lesson 10.2. So in our next lesson, we'll finish up module 10. So until then, I will see you soon.